Okay, so we're going to continue here. We left off with classification of matter. Now we're going to move to look at how we can classify matter as a mixture, or rather separate matter that has been classified as a mixture. So these are able to be separated because of different physical or chemical properties. So let's keep that in mind. So we might describe these physical and chemical properties later on. So we have various techniques that know how to exploit these properties and achieve separation. So something as simple as decanting. So say you have something that settles to the bottom of a mixture of liquid and solid. The solid can, settle at the bottom, and then we can just decant or pour off water or whatever the liquid is into another container to separate our mixture that way. There's also a process of distillation where now we have two different liquids that are mixed together, but they have different boiling points. So the one with a lower boiling point is more volatile, so it's easily vaporizable compared to the other liquid. So the more volatile compound will distill or boil off first, and then we can separate, two or more liquids if there's enough difference in their boiling points. There's other more types of distillation, such as a fractional distillation, where you can separate closer boiling points. But something like this is called a simple distillation, where we have over here on the left our mixture. We heat it up. It gets cooled down in this tube in the middle here, where we have water being pumped into this glass tube, and then there's a tube within a tube where our distillate kind of drips down. And as it's cooled from its vapor phase back down to liquid phase, we can see our pure liquid that has the lower boiling point that distilled first is now collected. Um, so we also have filtration. So now this is generally used when we have a liquid and solid. We can pour the liquid through a filter. The solid remains in this funnel here with the filter paper in it, and the liquid passes through. So we have distillation, filtration. These are again separating based on physical changes. So physical states are involved here. But no chemical changes will occur when we talk about just physical change and physical separation. So that means that the composition of our substance will not change. So the molecules that compose our substances do not change during a physical change. So you can ask yourself, as in the case of a phase change from ice, from solid water to liquid water, do I still have the same substance? And that will tell you that this was just a physical change, a change of phase, because I still have water at the end of my observation. But say you're observing a chemical reaction, something like flammability. If you light something on fire, you have to change its identity to witness that observation. So let's backtrack here to, again, physical changes. So I mentioned melting, where we go from solid to liquid water, but also boiling, when liquid water gets heated up enough energy is added, so those molecules can separate and turn into the gaseous phase here. But we still have water. Water before, liquid phase, water after. Now, when we talk about a chemical property such as oxidizing or rusting, you have to change your element here, in this case iron. You have to change the composition of what you're looking at to observe this chemical change of oxidation. So we have iron over here. We have these four Fe. So we see this kind of cubic repeat structure here, this nice ordered solid of iron, some oxygen interacts with this iron, and then we get rusting. So if you didn't know, iron oxide is rust, and this is considered a chemical change. We can ask ourselves that same question: do I have the same stuff that I started with at the end? The answer here is no. So that simple question tells us that we witnessed a chemical property of oxidation. We saw a chemical change occur. We do not have the same substance to start at the end. So here's kind of kind of a table showing us physical versus chemical changes. So we have a physical change up top here. Dry ice is subliming. So the process of going from solid directly to gas phase without a liquid phase is what carbon dioxide does here, this sublimation. It does not have a liquid phase at normal room temperature and pressure. When we talk about phase diagrams and things like that, we'll explain why. But this is called dry ice. It just goes right from ice or solid, cold CO2 to gas. Then we have solid sugar. We can see another physical change where our sugar just dissolves in water. So the sugar on the left here is a nice ordered crystalline pattern, but then over here we can see on the right it's separated by water molecules, those little red and white molecules in between. So this dissolve process is also a physical change. Then our third representation here, we have propane gas. So that's what those black and white balls are representing. We have three carbon atoms with some hydrogen atoms there, the white balls, and then we heat this up under oxygen. So the 5H2O is in that chemical reaction as well. But notice we can see visually we do not have propane any longer. We don't have that three carbon chain, but we have CO2 and H2O on our product side. And we can see that written in the chemical equation as well above. So we know for sure we observed a chemical property. We saw a chemical change. So again, in summary here, a physical property does not change the composition of your substance. You can smell something without changing it. So the smell of gasoline would be a physical property. Other things like taste, color, appearance, melting point, boiling point, density, all of these can be observed without changing the matter that you're observing. But then a chemical property, we need to change our substance, change our matter, some way to observe it. So flammability, we have to light something on fire to see if it's flammable, right? Chemical properties such as corrosiveness, acidity, toxicity. So an acid, to know that it's an acid, it would have to react with something that we call a base. Toxicity, that would have to have some negative effect on cells, something like that. So we would have to witness some type of chemical change. So here we have kind of like a question that summarizes what we've learned to see if we retain some knowledge here. So we have our diagram on the left representing liquid water in a pan. And then we're asked here, A, B, or C would represent these water molecules after they've been vaporized by boiling. So we're looking for just a phase change here, a physical change. So we can see answer choice A, we have one red ball, two white balls bonded to that. And that's represented by A. They're just further apart from one another now. So we still have water to start on the left, and then we have water on the right. What I would guess is in B and C, we have some hydrogen and oxygen gas, maybe in B, and then just some individual hydrogen and oxygen atoms in C. So we will stop here with this video and then continue with the next section next time.